Okay, this is David Cooper again, and this video is going to be the hardware overview. This is, in fact, what you're looking at, and I'll adjust it in a minute to see the touchscreen HMI at the top. But this will be what you will be using for the whole semester. What I'm going to do is explain the pieces of the hardware so you'll be familiar with them when you come to the first lab. So on the left, and you can kind of see my finger here, over here at the left, you will see what we call the operator pendant. And it's a series of push buttons, switches, and lights. We have on the PLC, by the way, programmable logic controller, or Allen Bradley, who is the manufacturer, likes to call it now a PAC, programmable automation controller, but everyone still refers to it as PLC, programmable logic controller. And it's a series, hardware-wise, of inputs and outputs. Inputs being commands that you send, hardware, in this case, hardware status commands that you send to the PLC, and the outputs are what it is doing to cause things to happen. And I will explain that in more detail in a minute. But the operator panel on the left is a series of push buttons, switches, and of course at the bottom you see an E-stop, which is a push button. And those are inputs to the PLC. And the first top three and the bottom E-stop has lights built into it, and that is an output from the PLC to turn on or turn off. And the fourth device down is a switch, and this next one right above the E-stop is a potentiometer. So I'll explain that as we go along. Not everything today, but a lot of it. So what you see in the middle right here is the PLC. And over here on the left are status lights. And basically to indicate whether the PLC is running or not running. Some status light for communications. It indicates whether you have a force on, which we will go into later, whether the I/O is okay or not, and some communication links. So basically they're to inform you. And in general, green is good, red is bad. Force is going to be an amber color, and so forth. Up here at the top, across here, there are 16 built-in inputs, 24 volts DC. That's the blue part on the top. The green part right under it is the outputs, 16 outputs, 24 volts DC, which is more or less the standard in the industry now. Over down here, you'll see, and it's kind of flipped vertically from horizontal, but the actual wiring from devices for the 16 inputs here and the 16 outputs over here. And you will receive a sheets of paper that describe how it is wired up. And not your first lab, but one of the early labs, you will do what's called I/O checks. And we'll do that as part of your lab. On the right here, and we won't use these at first, but we will get to them. There's 3 add-on modules. These are analog modules. The first one is a 4-channel analog input. The second one in the middle here is a 2-channel analog output, and the third one is a thermocouple module, which you see here, a thermocouple for measuring temperature. We will use all that. The 2 purple thingies right here are merely devices, and I'll hand out some information, post it also that describe what they're doing. These were bought early on as 4 to 20 milliamp inputs and outputs, and in our lab it's much easier to do 0 to 10 volt DC, so these are converters for that, and also one that converts the resistance of the potentiometer directly for the analog input. The potentiometer over here is an analog input. The meter up here is an analog output, and we will use those a little bit later in the semester. Over here, you notice right here with my finger, we have two ways to connect from the PC with the programming software to the PLC. And we will start off by using this one, which is a USB connector. And this end of it looks just like what I call a printer USB cable, and back to the USB input on the PC. So we will start by that. Eventually, it won't take long actually. On here at the bottom you see a couple, these are yellow, but they're Cat5 Ethernet cables, and your PLCs and PCs will be networked together on Ethernet, and you will switch over from the USB cable to the Ethernet cable, and all our PLCs will be networked together. That is also much faster, and you will learn some about these devices being networked on Ethernet. On our wall in the lab, we have a big switch that allows all these devices to be connected together. Now, I'm going to raise the camera just a little bit because, let's see if I can do this. You will see what we call an HMI, human machine interface, which is also a touchscreen, that a little bit later in the semester we will start using it, and you will learn to design screens. One of the first things you will do is more or less repeat the operator panel over here on the HMI and do it by virtual push buttons. But depending on how fast we are able to move during the semester, you will do a lot more screen design, and it'll be quite interesting. Most people really enjoy that because you can be quite creative when you're using that. Each of the devices, the touchscreen right here and the PLC right down there, has an Ethernet address already assigned to it, and we have to have fixed Ethernet IP addresses so that everything can reside on the network properly. Now I'm going to attempt, so don't mind me trying to move the camera so that we can do this. The other thing, I'm going to set the microphone down for a minute. Okay, that kind of gets it. You'll see it much better. I just want to make sure you're at least things that you see when you come into the lab are not first time to see it. But the other thing the PLC will control is what we call the Festo unit, made by a company called Festo. And basically it comes in 3 sections. Over here, if I can get over here, is what we call MechLab 1, the middle one is MechLab 2, and the third one is MechLab 3. It assembles pucks together, kind of like an assembly line, like a miniature Volkswagen line, if you want to call it, two different kind of pucks, and you'll see that my hand holding one side and the other side. And the purpose of this machine is to assemble those together, and that's one of the things you will do, is learn to program the PLC to do that. We will also be able to, you notice right here we have a silver one, and you will learn to program when the pucks come down the line. And over here you see a conveyor, and I'll give you a live demonstration of that when you get to lab. But I can reject a black puck, let me get it in front of the camera, or a silver puck as a bad puck, one or the other. It can see the difference in the two, and you will learn to do either and both. You can reject the black at one time as a bad part, or reject the silver as the bad part, and it will go down this slide right here and get rejected. And we will use the switch that I showed you on the operator panel to switch between reject black or reject silver. But the purpose of all this is for you to learn to do a assembly line and how to program it to operate correctly. And it's one thing to learn to operate it correctly, but it's another thing too is to make sure that it don't operate incorrectly. So there's some of both involved in that. So that is one thing you'll be doing, and you will learn to also do it from the touch screen, and also the monitor the touch screen as far as, you know, which lights are coming on. And this Festo is a combination of electric motor, pneumatic valves for movement, electric solenoids for movement, and so forth to make this operate properly. And if I have just overwhelmed you, don't worry about it. I can tell you from experience and from other classes that, you know, the overwhelming part goes away. It will become second nature to you, and you'll learn to do this, which is basically exactly what you'll learn to do when you go out into industry and doing this kind of work. So that is the pieces of the hardware. There is one more part of the hardware which we may or may not get to in the fall semester. We have been doing that in previous semesters. However, the COVID-19 has changed things, and I'm not sure this class will be the first class that will actually do the hybrid class of both online and on-site labs, and we will have to determine how fast it's going to go. We will not move faster than you guys can move. So what I'm talking about is to put AC, 460 volt AC induction motors onto variable speed drives, which are also hooked by Ethernet to this PLC. If we see we can get to it, we will. If not, it will be put into the spring semester of PLC 2. And hopefully all of you, some of you will have to, depending on what you're majoring in, won't. But I encourage everyone to take both semesters of PLC. Also starting in the spring, there will be at least one, maybe two, specialty PLC courses. One will be on safety PLCs, which we do have equipment for that now, and the other's motion or servo PLCs with the proper servo motors and drives for positioning. And that hardware is on a grant that we Don't know it's going to happen or not happen yet. Hopefully it will, and we can have the hardware. If not, it'll have to be delayed for a while. But anyway, we'll see what happens. So this video is an overview of the hardware that you can view from eLearn, so that when you come in for your first lab, it will be posted to eLearn before you start classes, so that you can look at that before first class. First class won't be a lab, as explained in the first video, that everyone will be here for the first class, and we will go over in more detail everything. But anyway, I wanted you to be able to at least get a feel for what you're going to use, what you're going to see, and so forth when you get to this class. I will guarantee it will be fun. So that's it for now. I will see you soon. Bye.